Have you ever wondered how astronauts manage when they need a tool or a spare part that wasn't packed in their spaceship before launch? The unforgiving vacuum of space doesn't allow for much error. You can't just pop to the shop when you're millions of miles from Earth. After all, preparing for a space mission is a bit like packing for the most extreme camping trip imaginable. Every ounce counts, with the cost of launching a pound into space running into the thousands of dollars. And then there's the issue of space, or lack thereof. When you're hurtling through the cosmos in a vehicle the size of a small house, there isn't room for an extensive toolkit or spare parts for every eventuality. And let's not forget about the uncertainty. Space is full of surprises, from unexpected equipment failures to scientific experiments requiring specific tools. Astronauts often find themselves needing something they simply don't have. So, how do we overcome these challenges? The answer may lie in a technology that's been revolutionizing manufacturing here on Earth: 3D printing. 3D printing, or additive manufacturing as it's also known, is a process of making three-dimensional solid objects from a digital file. It's like a high-tech version of sculpting, where an object is created by layering material upon material until the desired shape is achieved. But instead of clay or stone, 3D printers use materials like plastic, metal, or even ceramics. Now imagine taking this technology into space. Astronauts could potentially print the tools or parts they need right there in their spaceship. No need for massive cargo holds filled with just-in-case items. No more missions compromised by a lack of necessary equipment. The possibilities are as expansive as the universe itself. From printing a simple wrench to creating complex components for life support systems, 3D printing could be the key to unlocking a new era of space exploration. Imagine if we could print whatever we need right there in space. Well, the future is here. The application of 3D printing in space exploration is not a new idea. It has been a journey of several years filled with trials, errors, and triumphs. This journey began with the dream of creating objects on demand in the vast expanse of space. A dream that quite literally took flight when the first 3D printer was sent to the International Space Station in 2014. This wasn't just any 3D printer. It was specially designed to function in zero gravity, a feat that required innovative thinking and meticulous engineering. With this space-age printer on board, astronauts were able to create the very first object printed in space, a part for the printer itself. This marked a significant milestone in space exploration, proving that manufacturing in space was not only possible, but practical. This achievement was the result of a collaboration between NASA and Made in Space, a company dedicated to the development of off-Earth manufacturing. Together, they demonstrated that 3D printing could overcome one of the biggest challenges in space exploration: the need to carry every single piece of equipment from Earth. With the ability to print parts on demand, astronauts could potentially repair broken equipment, create tools, and even build structures using materials available in space. The success of this first space-based 3D printing experiment led to further advancements. In 2016, a second, more advanced 3D printer was sent to the International Space Station. This one had the capability to print not just plastic, but also metal, opening up even more possibilities for in-space manufacturing. And that was just the beginning. The advancements in 3D printing for space exploration have been nothing short of astronomical. As we continue to push the boundaries of what's possible, the use of 3D printing in space exploration promises to revolutionize the way we venture into the cosmos, making our dreams of colonizing other planets closer to reality. From printing a simple plastic tool, we are now looking at the possibility of printing complex machinery and even habitats using locally available materials. A leap this massive has been made possible due to the relentless advancements in 3D printing technology. We've come a long way since the first 3D printed object was created back in the early 80s. Today we're not just talking about printing with plastic, but with a wide range of materials, including metals and ceramics. This technique, known as multi-material printing, allows us to create more complex and functional objects. Imagine the potential it holds for space exploration. Astronauts could potentially print tools or parts with different materials depending on the requirement right there in space. A tool with a metal tip and plastic handle? No problem. Then there's metal printing, a game changer in the world of 3D printing. Metals like titanium, stainless steel, and even gold can be used as ink for 3D printers. This technology has already seen success on Earth, with various industries, including automotive and healthcare, reaping its benefits. In the context of space exploration, metal printing could be instrumental in creating strong, durable parts for spacecraft, rovers, or space stations. But perhaps the most fascinating advancement in 3D printing technology is the concept of using lunar or Martian dust as the ink for 3D printing. Yes, you heard it right. The idea is to use the resources available on these celestial bodies to produce objects, thereby reducing the need to carry materials from Earth. This concept, known as in situ resource utilization, is a major focus of NASA's research. One successful experiment that deserves a special mention is NASA's Refabricator. This 3D printer, which was sent to the International Space Station in late 2018, can recycle waste plastic materials into high-quality 3D printer filament. It's like having a mini recycling plant in space. The Refabricator has successfully demonstrated that we can produce, use, recycle, and then reuse materials in space. The potential applications of these advancements are mind-boggling. For instance, let's consider a mission to Mars. Instead of carrying all the necessary equipment from Earth, a significant portion of it could be printed on Mars itself using Martian dust. Even habitats for astronauts could potentially be 3D printed using local resources. This would drastically reduce the payload of spacecraft, making space missions more feasible and cost-effective. Yes, we are now at a stage where we can potentially print a habitat on Mars using Martian soil. The advancements in 3D printing are not just revolutionizing the way we approach space exploration, but also redefining the limits of what's possible. The future of space exploration is here, and it is being printed in 3 dimensions. 3D printing in space is more than a convenient solution to logistical challenges. It is a game changer that could redefine how we explore space. Imagine the possibilities of a technology that can make space missions more flexible, ambitious, and longer lasting. That's the promise of 3D printing in space exploration. It's not just about creating objects on demand, but about expanding the horizons of human exploration and discovery. Take, for instance, the manufacturing of spacecraft parts. Currently, every component of a spacecraft has to be designed, built, and tested on Earth, then sent into space. This process is not only time-consuming and expensive, but it also limits the kinds of missions we can undertake. What if a part breaks or malfunctions? What if astronauts need a tool they didn't know they would need? With 3D printing, those obstacles could become a thing of the past. Astronauts could manufacture spare parts right there in space, as and when they need them. This could drastically reduce the weight of spacecraft, making space travel more efficient and less expensive. It would also give astronauts the ability to respond to unexpected situations, making missions safer and more adaptable. But 3D printing's potential goes beyond spare parts and tools. Consider the possibility of building habitats on other planets. Instead of sending pre-built habitats from Earth, a process fraught with challenges, astronauts could use 3D printers to construct habitats on site, using materials found on the planet itself. This isn't just a wild idea. NASA's Mars Habitat Challenge, for example, has already seen prototypes for 3D printed Martian homes. These habitats could be built before astronauts even arrive, providing them with a ready-made base to kickstart their exploration. And then there's the potential for longer missions. Without the need to pack everything in advance, astronauts could sustain themselves for extended periods. They could manufacture what they need as they go, from tools to habitats to scientific equipment. This could enable ambitious missions that were previously unthinkable, from multi-year stays on Mars to voyages to the outer planets. The potential of 3D printing in space is truly limitless. It could revolutionize not only how we explore space, but also how we think about it. It could transform space from a hostile alien environment into a place where humans can live, work, and thrive. This is a technology that could redefine our relationship with space. It could make space exploration more accessible, more sustainable, and more exciting. It could help us push the boundaries of human knowledge and achievement. 3D printing could be the key to making our dreams of colonizing other planets a reality. So, what does the future hold for 3D printing and space exploration? As we venture further into the cosmos, the role of 3D printing is set to expand dramatically. It's not just about printing tools or spare parts anymore, but about creating entire infrastructures in space. NASA's Artemis program aims to return humans to the moon by 2024 and set up a sustainable human presence by 2028. A crucial part of this plan is the use of 3D printing technology. By using lunar soil or regolith as a building material, astronauts could potentially construct habitats, research facilities, and even roads. This would not only save on the enormous costs of transporting materials from Earth, but also pave the way for long-term lunar habitation. Across the Atlantic, the European Space Agency has a similar vision with its Moon Village concept, which imagines a sustainable human and robotic presence on the moon. A key component of this vision is the use of 3D printing to build everything from habitats to scientific equipment out of lunar regolith. But the journey to these ambitious goals isn't without challenges. There are questions about how to power these 3D printers in space, how to control the printing process in a zero-gravity environment, and how to ensure the durability and safety of the printed structures. These are hurdles that scientists and engineers are working tirelessly to overcome. And the implications of all this, well, they're nothing short of transformative. By enabling us to live and work in space for extended periods, 3D printing could be the key to unlocking the mysteries of the universe. It could open up new opportunities for scientific discovery, resource extraction, and even space tourism. And perhaps most importantly, it could help ensure the survival of our species by creating the possibility of human colonies beyond Earth. With 3D printing, the stars are no longer the limit, they are just the beginning. As we've seen, the potential of 3D printing in space exploration is truly mind-blowing. In our journey throughout this video, we have taken a fascinating trip from the dawn of a new era in space exploration to the mind-boggling possibilities that the future holds. We started by tracing the journey of 3D printing in space, from its infancy to the technological marvel it is today. We learned about the first 3D printed object in space, a wrench made aboard the International Space Station. This marked a pivotal moment in space exploration, demonstrating that astronauts could manufacture tools on demand rather than relying on resupply missions from Earth. Then we explored the advancements of 3D printing in space exploration. We discovered that this technology is not limited to tools and spare parts. Instead, it has the potential to create complex functional systems and even life-supporting habitats. We discussed the possibility of extraterrestrial 3D printing, where locally available materials such as lunar or Martian soil could be used as raw materials. This concept, known as in situ resource utilization, could revolutionize long-duration space missions, making human settlement on other planets a tangible reality. Next, we delved into the game-changing potential of 3D printing in space exploration. We looked at how it could transform the way we prepare for space missions, reducing the amount of cargo needed to be launched from Earth. This would not only save significant resources, but also increase the flexibility and resilience of space missions. We also touched on the idea of 3D printing satellites in orbit, which could drastically cut down the cost and risk associated with launching satellites from Earth. Finally, in the last segment, we glimpsed into the future of 3D printing in space exploration. We considered the exciting prospect of 3D printed habitats on the Moon or Mars. These habitats could be constructed using local resources, reducing the need for expensive and logistically challenging supply missions from Earth. This capability could fundamentally change the way we approach space exploration, paving the way for sustainable human presence beyond our home planet. 3D printing has the potential to take us to places we've only dreamed of. It is a technology that is pushing the boundaries of what is possible, opening up new frontiers in space exploration. The ability to produce what we need, when we need it, and where we need it is a game changer. It is not just about making things, it's about advancing our capabilities, fostering innovation, and ultimately expanding our reach into the cosmos. Who knows what the future holds? Will we see a 3D printed colony on Mars, a network of 3D printed satellites orbiting the Earth, or perhaps a 3D printed spacecraft exploring the farthest reaches of our solar system? The possibilities are endless, limited only by our imagination. One thing is for sure, with 3D printing, space exploration will never be the same again. So we've taken a captivating voyage through the breakthroughs of 3D printing in space, from the beginning of a fresh epoch in space exploration to the remarkable strides in technology, peering into a future that's as thrilling as it is unpredictable. Now it's your opportunity to engage. How do you perceive the future of 3D printing in space exploration? Can you envision residing in 3D printed habitats on distant planets? What will this technology mean for our approach to space exploration and life as we understand it? We're eager to hear from you, your perspectives, your inspirations, your queries. Don't hesitate to add your voice to the discussion by leaving a comment below. Let's begin dialogues about the future of space exploration. If you gain new insights from this, please express your appreciation by hitting the like button. Don't forget to subscribe and hit the bell icon to stay updated on our latest engaging content. And remember, knowledge grows when shared, so feel free to pass this video on to your friends and family, bringing them into the conversation about the future of space exploration. Together, let's interact with the future, push beyond our limits, and keep reaching for the stars. Until we meet again, keep exploring.